Well, thank you very much for taking the time to come and see us today. Well, we're going to talk about profiling BIP access patterns in user-centric data streams. The TLDR of that is basically trying to find out if a BIP account and a VIP account can vary depending on the context. And is at times is very difficult if you're able, for example, to do a lateral movement type of attack, like a pass the hash or pass the ticket, and impersonate a BAP account is almost impossible to tell if you follow patterns of behavior of an administrator, a technique that you can do post-exploitation, and that's what we're going to talk about today, how we're trying to approach this problem. So who are we? My name is Soto, and I've been in the industry for a little bit. I run a hackerspace here in Silicon Valley called Pacific Hackers. We also have a conference in November. And I'm here with Joe Zadeh, which is my partner in crime. We've been working together for over 4 years now. Since we started working together at Kaspita. Kaspita was a UBA startup, was acquired by Splunk. Then we were at Splunk for 2 years, and then we moved on to Jask, and now he's a core light. So, like I mentioned previously, the goal of this talk is the bottom line is, can we tell if a BAP account, either an admin, either a SQL is a root account, or a super admin? I've seen that in organizations. I have a very long tenure as a Windows engineer, and I've seen a lot of admins, sub-admins, and super admins. Can we tell if these accounts either have been compromised or they are behaving in a manner that is dangerous? So we will include a little bit of the malicious inside there. So how is this defined as VIP? VIP is defined as the account that has the most privilege within a system of application. We try to include application as well because we try to make the definition a little more broad than just simply root or system administrator. And because when you go to certain environments, there are levels and sub-levels of system administrators or super users. Usually, some of the privileges that these accounts have is they can create accounts, they can change user passwords, they can write or change log files, install software, add themselves to specific groups, create groups, take over specific files. And these accounts are needed because within an organization, you don't want to have a flat structure where everybody has the same privileges when it comes to creating administrative tasks or creating users or resetting passwords. So there's this sort of a hierarchy where basically you had to, if we follow the principle of least privilege, you had to obviously segregate duties, and you had to assign each user according to their tasks. And obviously you don't want to assign any user a task that would allow them to take over. That happens sometimes with administrator accounts. Has been seen in the past. I was part of a team that was protecting a organization. You probably guys heard of it if you've been in the industry long enough, where the system administrator had all their passwords in a Excel sheet. This individual was targeted. He was phished, and it resulted to be a nation state, and that nation state basically took over the organization, took over content. And what ensued afterwards was basically very stressful and difficult to deal with. So what happens sometimes is, depending on the organization and the way things are structured, usually you want to prevent somebody from taking over everything, and you want to distribute tasks and permissions and privileges accordingly to whatever the users or group of users are doing. And that's a way to at least the one-on-one of system administration. And basically, these are things that would allow you to keep your organization protected. I'll give you an example. I had a customer where basically they were attacked by ransomware, and because I set a GPO that basically said the user cannot write outside of their documents, ransomware came in, was executed, but all what was encrypted was the My Documents folder. So even though I had an S where the backup was written to, they couldn't write to the S. Even though I had a software and shares where they could pull software, or they could pull, for example, payroll, they couldn't get into it. And they couldn't get into it because they simply didn't have rights. And they couldn't pass the hash, because I do a little trick, which is I create an account just to join computers to the domain, then I disable it and get rid of it. So usually when you do that, you had to sort of remember what was the password for the administrator 500, because if you do that, then you're screwed. You have to reset. But usually that's one of the things I do in case somebody gets popped. They can retrieve the hash, and then obviously usually they will pass the hash and access everything. And if you had something like Eternal Blue, for example, which was one of the things that WannaCry was doing, then you can encrypt everything. So by this example, what I'm trying to explain is the relevance of the isolation of privileges and the power that these accounts have. So I think I've already been through this. The analog account in Unix or Linux systems is usually the root account. So usually we look either system administrator, NT system, or root. To put it a little bit more into a context of how these are defined contextually and conceptually, usually what is applied is what's called a role-based access control, RBAC. And RBAC basically allows you to create either organizational units or groups where you can then apply rights and apply privileges that supersede the individual that is inside that group or organizational unit. And it's usually very common in Active Directory environments. The Active Directory basically is the operational application of RBAC, and it's usually done through a protocol called LDAP. And LDAP can be used in Linux environments and Windows environments. Our investigation had mostly data from Active Directory. So here's a overview of how the permissions are usually distributed. You have the directory service. The directory service basically checks the schema. The schema is like this hierarchical information about who's who, what they do, what they can and they cannot do. It usually resides on the domain controller. And then from there, using diverse number of technologies, it gets distributed to the workstations, the servers, and ultimately the applications. Here's an example. Many of you probably are very familiar with this. This is how you manage an Active Directory. You have the users. The users can be moved into OUs. You can create groups. You can create different types of special groups if you want. In this case, basically what Active Directory allows you to do is basically get very granular on who does what and where can they do it. Like I was saying before, this can get complicated, and we want to say this is a caveat because this is an initial approach of this research, and there are environments where there are super admins, there are OU admins, there are hidden OUs, there are service accounts. Within my career as a system engineer, many times I was installing products where we had to test connection to LDAP, and then one administrator would see in a specific OU, and then the other wouldn't. Come to find out, and he didn't even know it, I guess because it was on a need-to-know basis. I was working with a company that basically they were making military, developing military helicopters. So there were a lot of OUs and parts of the schema that were not seen by everybody and that were seen by the specific individuals. Obviously, this makes this research a little more complicated and difficult. We try to basically approach this research in the context of a specific or reduced OU data, where we knew at least what accounts based on the schema and on the description of these users, what administrators, and if you even go into cross-domain trusts or forests, it gets even more difficult. So once we basically agree on what the VIP accounts, or what are the activities or the behaviors that VIP accounts have, we were able to do it by certain tasks. So in this case, we looked at backups, password resets, creation of accounts, software installs. And then basically the reason why we did this is because we needed to try to approach to see if we can tell what they're doing, if we can establish a benchmark of what they do, can we tell if they have been compromised either by an external actor or by a rogue insider. So it looks like I got 10 minutes, right? Yeah, so that means that we're gonna have to speed it up a little bit. So here's some of the quick reasons why you target VIP accounts. Here's one tool called Bloodhound that tells you almost like the degree of separation that you had to get domain admin. Obviously, if you get domain admin, you own pretty much everything. Here's a tool called Mimikatz. You're probably very familiar with this, where you could do things such as pass the hatch, and you can do pass the tickets. It's a little more difficult nowadays, but still can be done. Mostly if your force level is based on legacy, 2003, 2012, or 2008 rather. So these accounts can constantly target it. And lately what most of us have seen is phishing, spear phishing, because obviously, like I said before, I've been in situations where once the administrator was compromised, basically the organization was done. And there's been other cases, rogue insider, the administrator or a specific administrator leaves, takes the passwords or resets the passwords from others, and then it locks up or is able to exfiltrate information. So here's the problem. So I'm gonna let Joe take it from here, and he's going to talk to what we did with Kafka and how we approach this problem.
All right, thanks, Rod. Can you guys hear me okay? Yeah, now we're just going to kind of dive in the last few minutes here into some of like the technical implementation. We were kind of doing to prototype out this sort of kind of intuition about there's important users in enterprise data sets, and there should be a way to kind of fingerprint and maybe sort of assess automatically some notion of like risk the account represents to the overall kind of the overall sort of user hierarchy. So I think how we did this problem in an implementation perspective is just kind of more based on the constraints we were dealing with from the platform we were engineering. There's a lot of different ways you can attack this problem. I was originally exposed to it when I was still kind of helping with professional services engagements, and so you can kind of think of this as like a cookie cutter pattern we use at a few large customers doing consulting work. And the reason it's sort of a fun story to tell and kind of like extrapolate some of the ideas here is because sort of this workflow we're talking about led to like creating 2 prosecutable cases against insiders, so people who are stealing data and stuff like that in a really large kind of bank card network, or I don't know how to say it without giving it away, but it was basically a really big financial organization. One of the interesting problems we sort of had to think about this time for kind of modeling kind of important users in LDAP data was how to kind of do the anomaly detection or the scoring of the user behavior in a real-time framework. So in our implementation, we were using the Kafka Streams API and basically spinning up like a little distributed app that can run more. It's going to be more some of the scoring metrics I'll show you at the end here. So kind of like what happens with this algorithm is there's 2 kind of steps. There's a sort of a ranking step that is about kind of deriving information from whatever data sets we are sort of curating for the problem of like identifying specific user types. Typically for us, this is Active Directory in different forms, and kind of how we derive a behavioral fingerprint for the user activity is leveraging a lot of Kerberos in this case. So Kerberos is something we spend a lot of time kind of like cherry picking little pieces of that data into like an analytic schema. And also like the Kerberos ticket granted, which I'll kind of talk about in a little bit. But at the end of the day, we're sort of inferring this kind of like social graph, which is a relationship of inherited like permissions and trusts and how they can access certain resources. And so because there's sort of a graph kind of implicit in like the social structure of these kind of user accounts and sort of what their functions are, the first step in this problem was to model, like create sort of a nice scalable graph data structure to compute some classic graph metrics. So kind of what we have here is like the algorithm that we implemented broken down into steps. And basically what the point is to sort of kind of do some intuitive processing of a social network, like a website, or in this case, it's just like, it could be thought of as like something like Facebook, where there's a bunch of users connected. They may be connected between, they may be linked by devices or something else other than another user account. But because it's a graph, we can kind of leverage some best practices and assign a couple of metrics to the ranking of the users in this kind of large collection of sort of related entities. And so with graph, like with the graph, it gives us a couple of different like counts of metrics that are important. And we basically kind of have under the hood, it's kind of where we had to spend some time building up our sort of heuristic. So we're using PageRank, a couple of other kind of hand-built features to describe for each user the relative rank in the graph. That's kind of the key intuition for the first step. And then from there, we basically take a sort of a time, like a time series point of view for each user account that we find important. And I think maybe I forgot to say this, but the reason we sort of like ended up with these first 2 steps were kind of why we're sort of really thinking about what does it mean to be like a high risk individual in an organization in terms of their potential to just elevate trust or target like different keys to the kingdom, like like walking an LDAP tree is a perfect example of a sort of a attack technique we'd see a lot when kind of a campaign was successful and the target was like just exfiltrated with all the user accounts. So we're just kind of going after these accounts that are able to do a lot of high profile permission changes, and in this sort of this metric, like we have a just like an intuition for reducing false positives. I mean, it's not really said here explicitly, but step 1 and step 2, the first time I implemented this algorithm, we weren't doing any sort of like ranking of important individuals. And what happened was, when we kind of get to the actual meat of this algorithm, which is kind of this little graph here, so for every user in the environment, you kind of get this graph. It's like called a heat map. But really what it is it just kind of tells you, like in a nice simple picture that's going to be represented by like a single number when we hit it with a special algorithm. This single picture of user activity is something we can kind of maintain in a nice scalable distributed fashion. So it's kind of like a really lightweight way to sort of hack a baseline together of internal access patterns. So this is more like east-west kind of behavior, where typically some of the stuff we'd be leveraging is about kind of Kerberos authentications and tickets being granted from kind of Windows resources. This kind of gives us visibility into those access patterns, where oftentimes in a large organization, like if the traffic isn't routed through kind of borders or kind of north-south, we kind of lose visibility at scale. So this was kind of a way to kind of get around that, see some sort of insights in the LAN. And then kind of the modeling of the VIPs is sort of a fancy way to say, like, we got to figure out ways to reduce false positives that are clever. The issue we had when we ran this algorithm at like some Fortune 10s was that the time to validate, like for an operator to like basically escalate a ticket around this and say, oh, we might have an admin account compromised. We got to go, pull all the servers and just kind of, do the triage associated with something, and, like that is specific just to like the LDAP and Windows environment, and also kind of the network-centric behavior in the LAN. It would take, on average, the operators in these large organizations, like 24/7 SOCs, I think it was 20 hours of working time to open and close a case around this algorithm. So it's, it has its drawbacks. But if you're able to, oh no, man, I think I picked the wrong slide deck. Crap. I mean, there's basically like, I missed one picture here. This is like an older version, but, did we lose it? There was basically one more picture that's gonna, like what happens with the scoring step for every person's individual kind of like set of access patterns is we hit this with an algorithm that's called PCA or SVD. All it does is it takes a matrix under the hood. This is a matrix of counts, and the x-axis is just sort of units of time, usually days or weeks. And what we do is we end up only scoring matrices or heat maps of users that we think have a high risk. And this lets us kind of target a very small subset of the population that poses like a larger risk, and also can make the alerts manageable. Like if you don't kind of do some of this kind of clever filtering, you can run into a lot of just strange access patterns. Like the key idea here is like after you're sort of running our algorithm and you kind of build up a picture of usually it's weeks of time, and for an average user, like I've done tests on my account when I was at like EMC, and I'd have about maybe 50 rows. Each row is sort of like a share or an asset that's being accessed. And so when you kind of look at like what happened with the people who were prosecuted because of this, so 2 admins basically were fired at a really large financial organization. The day they were fired, like, or maybe like the last 2 days, basically like their heat map history here, which I had a picture, and I'm sorry, I think I just screwed the slides up somehow at the last minute. But basically we add like one more day of information, and you see the, like intuitively in the kind of the coloring of the access patterns, there's a really noticeable deviation just with the naked eye. And the way we're able to sort of like kind of hack together an algorithm that sort of targets that intuition is for every update to this matrix, we run something that gives us a single number. It's the principal eigenvalue in PCA. And basically, we update the matrix with a new day of information, we compute that number again. If the two numbers are different by like a threshold that we sort of define with the organization itself, we basically have an anomaly, and that's where we sort of kind of go after the investigation side of things. So this was just sort of like a way to kind of build a prototype around this problem with some interesting like architectural constraints. Mainly the real-time constraint makes us sort of choose like a real lightweight representation of users' access patterns. And yeah, so I think
I think we're out of time, right? Okay. Do we have a Q&A, or that's it, we're done?
Any questions from the crowd? Because there are none online. No. Well, you guys have 2 more minutes if you want to tell us some more cool stuff about your algorithm. Oh.
Okay.
I'm a little confused. Which matrix do you take the SVD decomposition for? Is it for the time series, this matrix?
Yep. So on each one of these sort of like bins with which we sort of bucket time over, could be like this could be an hour, just some resolution we choose. Like for the real sort of production environment, we have maybe 40, 50 days of individual data. And then we build this graph, which is a single matrix. Each one of the column rows is basically just a count, or normalized count. And then when we get a new day of data, or we have enough information to update this matrix, we build another one, and we compute SVD on both of those. The one that was from like the day before, and then the one that's current. And then we just take the first eigenvalue from kind of the result of that computation to give us sort of an approximate number that sort of represents the current state.
And the latest column could affect if there's a big anomaly.
Yeah, exactly. That's the key intuition. Yeah.
Oh, interesting. Thank you.
Well, thank you guys. It's been a pleasure. Great job.